Hey friends, this is Venkatesh. Now I am going to give brief description about the regression models. And the content of this slide is what is regression and what are the different type of regression analysis and what are the important steps for modeling and linear regression assumptions and linear model equations. So please let me know if you have any doubts and queries in any part of this video. I will try to resolve as soon as possible. So now let us start. What is regression? Regression is one of the most widely used statistical technique in the analytical industry, and we can apply this technique to estimate the relationship between response variable and other one or more independent variables. And the regression is very powerful statistical modeling technique that can be used to generate insights of customer behavior in understanding business trends and factor influencing the business profitability. And also we can build the better model. Now let us discuss different type of regression analysis. We have the linear regression. So within linear we have two types. One is a simple linear and another one is a multiple linear regression. So simple linear means it's a one independent variable and one dependent variable. And if it is multiple linear means if it is one dependent variable and one or more independent variables. And the next model is a stepwise regression. And the stepwise regression we have three different types. One is a forward selection, backward elimination and bidirectional eliminations method. And the quadratic regression, this is a non-linear regression model. The next one is a logistic regression and the last one is a right regression. So now let's see one by one. The linear regression model is y equal to a plus bx plus epsilon. So y means it's a dependent variable and a means it's a constant, b is a coefficient, x is independent variable and e is error term. Suppose if we have more than one independent variable, then we can increase the x, that is multiple independent. The next one is a stepwise. So the stepwise, suppose if we have multiple variables, then we can go for a stepwise. This is also better choice. And already we saw the stepwise we have three types. The forward selection means the forward selection starts with the most significant predicator in the model and adds variable for each steps. And backward elimination method means it starts with all predicator in the model and remove the least significant variable for each steps. And bidirectional elimination means it add and remove predicator as need for each steps. And the main objective of stepwise regression is this modeling technique is to minimize the predicator power with minimum number of predicator variable. It is also one of the method to handle higher dimensity of data sets. The next one is quadratic regression. This will come under the nonlinear regression model. This line is it's kind of U type. Suppose our data is not following the linearity, we can go for the quadratic regression models. Next one is a logistic regression. Logistic regression is used to find the probability of event like success or failure, and we should use logistic regression when the dependent variable is binary. Ridge method is used when the data suffers from multicollinearity. Generally, ridge regression is used to reduce the standard error. The next slide. is steps for regression modelings. And the first step is a variable selection, second one is a scatter plot, third one is a correlation test, hypothesis test, and regression analysis and residual analysis. And the objective of the variable selection is a very important. Suppose, okay, I will give one example. Suppose your manager is asking you to identify the actual effort of the requirement. In this case, actual effort is our dependent variable. And the independent variable, we have a lot of independent variables because the requirement analysis and the code complexity, lines of code added, modified, reused, deleted, and resource skills, resource experience, team size, platform, software. Like this, we have so many independent variables. Here, the challenge is we have to identify the right independent variables because otherwise we will receive the unexpected result. So if we are not choosing the right independent variable means what are the problems will occur. For example, sometime some of the variables have the large outliers and also there is no relationships between the dependent and the independent variables and high multicollinearities. So these kind of problems will come. So we have to choose the right variables. The next one is scatter plot. So scatter plot is also one of the best option to identify the right variables. So mainly the scatter plot is used for data visualization. And the next one is a correlation test. So the correlation analysis is used to identify the relationship between two variables. Generally the correlation range is -1 to +1. So the -1 means it is perfectly negative correlation and +1 means it is a perfectly positive correlation. So next one is hypothesis test. Hypothesis test is used for goodness of fit and decision making. The next one is a regression analysis. The regression analysis is used to identify the relationship between two variables. And the last one is a residual analysis. That is a model validation. So you can see the scatter plot with R. See the first plot, it is a R plus 1. Simple R means small r means this is a correlation coefficient. So plus 1 means it's a perfectly positive correlation. The second graph is it is a perfectly negative correlation. That means R equal to -1. The last one is R equal to 0 means there is no correlation between the variables. So suppose if there is no correlation, then we should not use the linear model. We can go for some other models like Reg or some other models. So our next slide is some of the important assumptions for linear regression. Actually, this slide I have prepared for only linear model. So the assumption for linear regression is first it should be a linear relationship between the dependent and independent variables and it should not be the outliers and there is no multicollinearity and error should be normally distributed. So these are all the important assumptions our data should be followed. Then only you can go for the linear regression model. So the next slide is the linear model equations. The linear equation establishes a relationship between dependent and one or more independent variables. See the equation, the linear model equation is y equal to a plus bx plus e. A is intercept, b is slope of the line, and Web's long is error. And this equation can be used to predict the value of target variable based on given predicted variables.